The year was 1945. As the embers of global war cooled, a new chill began to creep across the continent. At the Allied Victory Parade in Berlin, Soviet forces unveiled a machine that would forever alter the calculus of armored warfare: the IS-3 heavy tank. Western generals looked on, and their peace of mind simply evaporated. Here was a steel behemoth whose radical, sloped armor was engineered to deflect incoming shells from nearly any angle. Armed with a fearsome 122mm cannon, it seemed invulnerable to anything in the arsenals of Europe or America. A new epoch of tank design had begun. A frantic race where every nation scrambled for an answer to the Soviet threat. And from the quiet forests of neutral Sweden, an answer would come. A solution so radical, so utterly unconventional, that it has never been repeated. By the early 1950s, the Swedish army relied on the British Centurion, a formidable tank forged in the final days of the Second World War to counter German Tigers and Panthers. It was a fine machine, with a superb gun and reliable armor. But Swedish commanders knew it was a tool for a bygone war. The Centurions were too slow for the fluid, hit-and-run tactics their defense doctrine required. They were vulnerable to new Soviet munitions and utterly ill-suited to the harsh Scandinavian landscape of boggy forests and rocky highlands. In 1951, the company Landsverk received an ambitious directive: design a new Swedish heavy tank that would surpass every other vehicle on Earth. The project was codenamed KRV. Engineers poured into it the most advanced and riskiest technologies of the era. The design called for an oscillating turret with an automatic loader, a colossal 150mm main gun, and armor capable of withstanding any known anti-tank round. On paper, the KRV was a monster, a single machine capable of halting an entire enemy column in its tracks. But reality, as it so often does, proved far crueler than the blueprints. When the first prototypes rumbled onto the testing grounds, it became painfully clear the project had reached a dead end. The fiendishly complex oscillating turret failed constantly. The autoloader would jam after just a few shots, and the vehicle's towering silhouette presented an almost perfect target. Worse, the cost of a single unit had spiraled beyond all reason. The Ministry of Defense had to admit the bitter truth. Sweden simply could not afford to build these flawed titans in any meaningful number. The KRV project was frozen, then cancelled, leaving the Swedish army with no path forward. It is in such moments of total failure, in the ashes of grand ambition, that true genius often finds its opening. And onto this stage stepped a young, impossibly brilliant engineer, whose name would be etched into the history of armored vehicles: Sven Berge. In the quiet, methodical halls of the Swedish Defense Materiel Administration, an engineer named Sven Berge proposed an idea. An idea so utterly mad, his colleagues initially dismissed it as a poorly conceived joke. But Berge was not joking. He was deadly serious, for his conclusion was born from a haunting journey into the recent past. He had undertaken a colossal study, immersing himself in the ghostly archives of the Second World War and the Korean War. He analyzed the outcomes of every major tank battle, sifting through thousands of combat reports, studying the grim, twisted shapes in photographs of knocked-out machines, and poring over forensic damage assessments. The results of his work were staggering. The statistics he uncovered were relentless, a brutal arithmetic that showed no mercy to traditional tank design. More than 50% of all tanks destroyed in these conflicts had received their fatal blow directly to the turret. This rotating citadel, with its complex turret ring, its traverse mechanisms, and its comparatively thin roof, was revealed to be the single most vulnerable component of any fighting vehicle. A shell striking the junction between the turret and the hull would often jam the rotation mechanism, instantly transforming a potent weapon into a fixed, helpless target. A direct hit to the turret's side could slice through its thinner armor, killing the crew or detonating the ammunition stored within. Even the falling shrapnel from artillery shells and aerial bombs raining down from above could puncture the roof armor and silence the machine forever. From this mountain of grim data, Sven Berge drew a conclusion that would upend the entire philosophy of Swedish tank design. He asked a question so simple it bordered on heresy. If the turret is the tank's greatest weakness, then why does it need one at all? What if one could create a combat vehicle completely devoid of this inherent flaw? A tank without a turret, he reasoned, could be made incredibly low, a predator hugging the earth, drastically reducing its visibility on the battlefield. All the weight saved from eliminating the turret and its heavy mechanisms could be redirected into the frontal armor, forging a glacis plate so thick it would be practically invulnerable to a head-on attack. Furthermore, the absence of complex rotational machinery would simplify the entire design, making the vehicle cheaper to build and far more reliable in the unforgiving conditions of combat. Berge's colleagues, of course, objected. They argued that without a turret, a tank couldn't traverse its gun quickly onto a target. It would be clumsy, a sitting duck in the fluid, fast-paced reality of maneuver warfare. But the young engineer had already anticipated this problem. His solution was just as radical as his initial premise. He proposed an entirely new system of aiming, one where the entire hull of the tank would become the traversing platform for the gun. Horizontal aiming, he explained, would be accomplished by turning the tracks in opposite directions, allowing the vehicle to pivot on its own axis with surprising speed. Vertical aiming would be controlled by a revolutionary hydropneumatic suspension, a system that could raise or lower the front of the hull, tilting the massive cannon as if the machine itself were bowing or rearing up. By 1958, the Swedish government, desperate for a replacement for its aging British-made Centurion tanks, decided to take a monumental risk. They greenlit Sven Berge's experiment. An order was placed for the construction of 2 prototype turretless tanks. No one in the world had ever seriously attempted to create such a machine for offensive operations. The Swedish engineers were, in effect, stepping into the great unknown. Ahead of them lay years of trials, of frustrating setbacks and astonishing triumphs. But at the end of that road waited the most unusual tank of the Cold War, a machine that would terrify military experts across the globe. It was more than just a new vehicle. It was a physical manifestation of a disruptive idea, a testament to the power of questioning the unquestionable, and a permanent alteration of what was thought possible in the world of armored warfare. They arrived at the proving grounds in 1959, and the testers understood at once. They were dealing with something fundamentally new. The machine's form was so unconventional that even the most seasoned armor crews were initially unsure how to approach it. Where a familiar silhouette should have been, with its commanding, turreted profile, there was only a low, armored wedge, a blade of steel that barely crested the horizon. Its main gun protruded directly from the frontal plate of the hull, as if it had grown there, an organic part of the beast itself. The entire impression was of a predator pressing itself into the earth, attempting to merge with the very landscape it was designed to defend. It was a radical departure from everything they knew. After a year of intensive trials, 10 more pre-production vehicles were constructed. They received an official designation, Stridsvagn 103, which, translated from Swedish, meant simply battle tank. It was soon shortened to STRV 103, or, more famously, the S-tank. But full-scale production would have to wait. It began only in 1967, once every system had been refined and had endured thousands of hours of punishment in the harshest conditions the Scandinavian wilderness could offer. The first thing that truly astonished engineers was its power plant. For the first time in global tank design, Swedish engineers had installed two completely different engines in a single chassis. A multi-fuel Rolls-Royce diesel engine, producing 240 horsepower, worked in tandem with a Boeing gas turbine that could generate an additional 330 horsepower. Such a solution seemed needlessly complex, almost redundant, but behind it lay a cold, hard logic dictated by the brutal realities of a potential war in Northern Europe. The diesel engine provided for economical long-distance marches and, crucially, near-silent movement during patrol and ambush positioning. The gas turbine, however, could be fired up instantly in any freezing cold and delivered a massive surge of power, a violent burst for a sprint from cover or a desperate maneuver under enemy fire. The design allowed each engine to be used independently, or both could be engaged simultaneously when maximum power was demanded. When the two power plants worked in concert, the nearly 40-ton tank could accelerate to 50 kilometers per hour, an excellent performance for its era. It soon became clear, however, that the American Boeing turbine lacked the raw torque needed to confidently master the most challenging terrain. Swedish engineers swiftly found a replacement. The modernized B version was fitted with a far more powerful Caterpillar gas turbine, boasting 490 horsepower. This new iteration also received night vision devices and a laser rangefinder, dramatically enhancing its combat effectiveness in the gloom of the long Nordic nights. But the true engineering masterpiece was the hydro-pneumatic suspension, developed specifically for this machine. In a conventional tank, the suspension's primary role is simply to smooth the ride for the crew. Here, it performed an entirely different and far more vital function. This intricate system of hydraulic cylinders and pneumatic shock absorbers allowed the crew to raise or lower any part of the hull, independent of the rest. It could kneel, it could lean forward or backward, it could tilt to one side. This wasn't for comfort, it was for aiming. The entire vehicle had become the gun mount. The S-tank was more than just a piece of military hardware. It was a philosophy cast in steel, a unique answer to a uniquely Swedish problem. It was a silent hunter, born of the cold forests and frozen plains, a machine that sacrificed convention for the ultimate advantage: to see, but not be seen. It could raise its nose to the sky or bow its head to the earth. It could list its entire hull to the right or to the left, all with the precision of a fraction of a degree. This was how the vertical traverse of its rigidly mounted cannon was achieved. When the new Swedish tank needed to elevate its barrel, the forward support wheels would climb upwards, lifting the entire front of the machine. To depress the gun, the wheels would lower, and the tank would seem to genuflect, pressing its nose toward the ground. From the outside, the effect was almost mystical. A colossal armored machine, swaying gently as if it were a living creature, stalking its prey. Horizontal aiming was at once simpler and infinitely more complex. The tank's tracks could spin in opposite directions, pivoting the entire chassis on its own axis. The speed of this rotation was, frankly, staggering. Between 45 and 90 degrees per second, depending on the terrain. On solid ground, the tank could pivot 180 degrees faster than a conventional turret could ever hope to turn through the same arc. This radical system of targeting gave birth to a unique and unprecedented distribution of duties within the crew. The driver of the Stridsvagn 103 was simultaneously the gunner, for it was he who controlled the vehicle's every minute movement and the articulation of its suspension. The commander was positioned beside him and had his own complete set of controls, allowing him to seize command of the entire vehicle at a moment's notice. This meant the commander, too, could lay and fire the gun, maneuvering the hull himself. But it was the third crewman who occupied the most unusual station in the entire history of tank design. The radio operator sat with his back to the direction of travel, facing the stern of the tank. And before him was a complete, fully functional driving station. In a critical situation, when the machine came under fire and an immediate retreat was necessary, the radio operator would instantly take control. He could guide the tank out from under the enemy's guns without losing precious seconds on a cumbersome turn. The driver, meanwhile, could continue to observe the enemy or prepare a return shot. The Stridsvagn 103 became, in effect, the only tank in the world that could be driven and fired simultaneously by a single human being. Any one of the three crew members was theoretically capable of fighting the machine alone, granting it an incredible degree of survivability. If the commander or driver were incapacitated, the remaining crew could continue the fight with almost no loss in combat effectiveness. This resilient crew was nestled in the forward section of the hull, shielded by formidable frontal armor. The upper glacis plate was set at an extremely acute angle, multiplying the probability of a ricochet from incoming enemy shells. The effective thickness of its frontal armor exceeded that of most contemporary tanks, while its low silhouette made simply hitting the vehicle an incredibly difficult task. It was a machine born not from convention, but from a cold, hard look at a nation's needs, a perfect answer to a very specific question. It remains a testament to the idea that sometimes the most brilliant path forward is the one that no one else dares to travel. The beating heart of Sweden's audacious turretless tank was, paradoxically, a familiar one. The legendary British 105mm rifled cannon, produced under license in Swedish factories. This was the same formidable weapon that had already proven its deadly efficiency on the Centurion tank, widely considered one of the finest cannons in the Western world. But where others saw a proven design, Swedish engineers saw untapped potential. They were about to unlock its capabilities in a way no one had ever imagined. The secret lay in a revolutionary automatic loading system, a symphony of steel and hydraulics that transformed an already fearsome gun into a true rapid-fire engine of destruction. The entire ammunition supply, a complement of 50 shells, was housed in a specialized magazine nestled in the rear of the hull. From there, a mechanical conveyor mechanism would snatch a shell, orient it, and deliver it directly to the breech. The entire cycle, from the violent recoil of one shot to the readiness of the next, took mere seconds. The result was a practical rate of fire of 15 rounds per minute. This was, to put it plainly, double the capability of most tanks of that era, where a human loader, a physically taxed crewman, had to manually wrestle heavy projectiles into the cannon's breech in a cramped, violent space. Theoretically, the system's absolute maximum could reach an astonishing 24 rounds per minute, but in practice, such a blistering pace would lead to the rapid overheating of the barrel and extreme wear on the mechanisms. Nevertheless, even the standard 15 rounds per minute gave the Stridsvagn 103 a colossal advantage in any armored duel. While an enemy crew struggled to load and fire 3, perhaps 4 rounds, The Swedish machine could unleash an unrelenting squall of steel, multiplying the probability of a kill with every passing second. This autoloader also solved another, more human problem. It allowed the crew to be reduced to just 3 men without any loss of combat effectiveness. By eliminating the loader, a role demanding immense physical strength and endurance, the engineers freed up critical internal volume. This, in turn, allowed them to make the entire vehicle even more compact. The gun itself was fixed rigidly into the frontal armor plate, canted at a slight upward angle, its long barrel projecting far beyond the hull's dimensions. The tank's total length, including the gun, was nearly 9 meters. Yet its width did not exceed 3 meters and 70 centimeters, and its height barely reached 2 meters and 14 centimeters. For comparison, its American contemporary, the M60 Patton, towered over the Earth at more than 3 meters, presenting a far more conspicuous and vulnerable target. As armor technology evolved, so too did the S-tank's bite. The modernized C variant was equipped to fire armor-piercing fin-stabilized, discarding sabot rounds. These projectiles killed not through brute mass, but through monstrous velocity and a hyper-dense tungsten alloy core designed to punch through hardened steel. This ammunition gave the tank the ability to defeat even the most heavily protected adversaries at ranges exceeding 2 kilometers, making the Swedish machine a lethally dangerous opponent, especially in a defensive battle. To supplement this main armament, the tank carried 3 KSP-58 machine guns, the Swedish incarnation of the famously reliable Belgian FNMAG, chambered in 7.62 mm, and renowned for its own rugged dependability. The Stridsvagn 103 was never just a tank. It was a statement of national will, a declaration that a nation could forge its own path, answering a universal threat with a uniquely tailored solution. It stands as a monument to the idea, that true innovation, of Fenchel purpose. 2 machine guns were fixed to the frontal armor, flanking the main cannon's housing. Their purpose was brutally simple: to sweep away infantry or shred any light vehicles that dared to venture too close. A third was mounted on the commander's cupola, a final line of defense that could be angled towards the sky, spitting fire at low-flying helicopters or attack aircraft. The combat weight of the initial production models was a considerable 39.7 tons. But as the decades passed and modernizations were bolted on, this figure crept upwards, eventually settling at a formidable 42.5 tons. This immense pressure was distributed evenly across its wide tracks, allowing the machine to demonstrate a surprisingly nimble performance over broken ground. It could scale vertical walls up to 90 centimeters high, cross trenches more than 2 meters wide, and without any special preparation, ford water obstacles up to 1.5 meters deep. But the true surprise, the feature that left many contemporary observers speechless, was the STRV-103's ability a special canvas flotation screen around the hull. The tank, this beast of steel and fire, transformed into an ungainly but effective boat. A water jet propulsion system could push the multi-ton machine through the water at 6 kilometers per hour, enabling it to cross the countless rivers and lakes of the Scandinavian theater without the need for vulnerable pontoon bridges. For a nation defined by its waterways, this capability was truly priceless. Another unique element of its design was the integrated dozer blade, a standard feature for every tank. Upon arriving at a pre-selected position, the crew, in a matter of minutes, could excavate a fighting position and drive the vehicle inside. It would vanish, almost completely concealed from enemy observation. All that remained above the surface of the earth was the low silhouette of the commander's cupola and the barrel of the main gun, ready to deliver a killing blow to an approaching enemy. This tactic was the physical embodiment of the Swedish army's defensive doctrine. The nation had no ambition for offensive wars, but it was grimly determined to turn its own territory into a death trap for any potential aggressor. The STRV-103 tanks were designed to occupy these camouflaged positions along the edges of forests, at critical road junctions, and within narrow mountain gorges. From these ambushes, they would eviscerate advancing enemy columns. The fire control system was a marvel, constantly refined throughout the vehicle's service life. The B variant received a laser rangefinder, which could instantly calculate the distance to a target with an accuracy of mere meters. A sophisticated ballistic computer automatically occurred the gunner with a perfect firing solution. Advanced night vision systems allowed the crews to hunt and kill in absolute darkness, granting Swedish tankers a crucial advantage during the long, unforgiving Scandinavian winters. Yet, Sweden's long-held status of neutrality meant that its radical, turretless tank never fired a shot in anger. It never faced a true test in the crucible of combat. It was a silent guardian, a steel specter that haunted the forests and fjords. Its existence was a paradox, a weapon of immense destructive power whose ultimate victory was that it never had to be used. The proving grounds of West Germany became the stage for a quiet revolution. Amidst the familiar silhouettes of NATO armor, a strange, wedge-shaped silhouette from Sweden, the Stridsvagn 103 was finally given its chance to perform before the world's foremost military experts. The results of these demonstrations would send a shockwave through the global tank community, a jolt of disbelief and profound respect. On the firing ranges, Swedish tankers began to accomplish the impossible. Time and again, their machines would strike targets with the very first shot, at distances once considered the absolute limit for tank gunnery. The NATO observers, initially skeptical, could only watch in astonishment, noting the phenomenal, almost unnerving accuracy. The secret lay in its radical design. A gun rigidly furret introduced minute errors into aiming. The Swedish machine aimed with its entire body. When the moment came to fire, the barrel was as steady as the earth it stood on, an unyielding extension of the vehicle's mass. Its performance in defensive maneuvers was particularly breathtaking. The tank would settle into a hull-down position behind a natural rise in the terrain, exposing nothing more than a few centimeters of its commander's cupola over the crest of the hill. The observer would spot an approaching target, relay the information, and the entire machine would rise with a silent, fluid motion on its hydropneumatic suspension, lifting just high enough for the gun to clear its cover. A single, precise shot would crack through the air, and in the next instant, the tank would sink back down, vanishing completely from the enemy's line of sight before they even had time to register the threat. It was a phantom, a ghost on the battlefield. Even the most hardened skeptics were silenced by its agility. Before the exercises, a consensus had formed among many experts. A turretless tank would be utterly helpless against an attack from the flank. The Stridsvagn 103, however, shattered this conviction with brutal efficiency. It could pivot in place faster than most conventional turrets could traverse the same angle. On firm ground, a full 180-degree turn to face a new threat took less than 4 seconds. Before an enemy could process the maneuver, the Swedish gun was already aimed and ready to fire. This nimbleness extended to the unforgiving terrain it was born to defend. Its low center of gravity and compact dimensions allowed it to navigate ground where taller, more cumbersome machines would bog down or risk capsizing. In the dense Scandinavian forests, where trees grow so tightly packed that a normal tank can barely force its way through. The STRV-103 moved with an almost balletic grace, exploiting every clearing and ravine. In the aftermath, military specialists were forced to concede that the Swedish oddity was, in certain critical aspects, not merely an equal, but a superior to the recognized titans of tank design. It was hailed as the ideal machine for defense and ambush, a veritable nightmare for any aggressor foolish enough to set foot on Swedish soil. Yet, for all its brilliance, these same experts recognized the profound problems that made its adoption by other armies an impossibility. The first and most damning flaw was the sheer complexity of its maintenance. The dense, claustrophobic internal layout, where every cubic centimeter of space was exploited for maximum efficiency, turned even the simplest repair into a grueling ordeal for the mechanics. It was a watchmaker's design in a blacksmith's world. This machine, so elegant and deadly in combat, became a frustrating, intricate puzzle the moment it returned to the workshop. It was a weapon perfectly honed for a single specific purpose: the defense of its homeland. It teaches a hard lesson in the calculus of war, that sometimes the most brilliant solution for one problem is no solution at all for the rest of the world. Perfection, it seems, is often a matter of geography. To reach the heart of the machine, to access the power plants nestled deep within its hull, was not a simple task. It was a grueling, invasive surgery. The main armament, the very soul of the tank, first had to be painstakingly dismantled. Then, the heavy upper armor plate of the hull could be unbolted and removed, peeling back the beast's protective skin. Only after this ordeal could the repair team finally gain access to the engines and the transmission. In the chaos of the field, under the threat of enemy fire, such an operation was practically impossible. Even within the controlled environment of a fully equipped workshop, with a full array of tools and heavy lifting mechanisms, the disassembly consumed more than 4 hours. This meant a tank with a failed engine was not just temporarily sidelined. It was effectively removed from the order of battle for a prolonged, dangerous period. This stood in stark contrast to most of its contemporaries, whose entire power packs could be swapped out in under 2 hours, often directly in the field. The twin-engine configuration, the very feature that promised so many advantages in combat, revealed itself to be a logistical curse during peacetime and exploitation. Each engine demanded its own separate maintenance schedule, its own distinct inventory of spare parts, and its own uniquely trained specialists for repair. The diesel and the gas turbine operated on fundamentally different principles, possessed different service lives, and suffered from entirely different typical failures. The logistical burden for a single armored unit was multiplied many times over compared to formations using conventional single-engine machines. And then there was the thirst. The gas turbine was infamous for a voracious appetite for fuel that shocked even the most hardened supply officers. When maneuvering at maximum speed, with both engines roaring in unison, fuel consumption reached astronomical levels. The officially stated range of 390 kilometers existed only on paper, a theoretical maximum achievable only when moving economically on the diesel engine alone. In the brutal reality of combat, where sudden bursts of speed and frantic maneuvering are the currency of survival, the tank's operational radius was slashed in half, and sometimes by as much as 2/3. The machine's cross-country performance, despite showing good metrics in forests and on firm ground, had its own Achilles heel. The relatively short track runs, combined with the vehicle's considerable mass, resulted in a specific ground pressure of 1 400 kilograms per square centimeter. For comparison, The West German Leopard 1 exerted a pressure of just 0.88, while the British Centurion sat at 0.95. This meant the Stridsvagn 103 would sink deeper into soft earth, bog down in marshy soil, and founder in deep snow, losing its precious mobility in the very environments where it was needed most. But its most substantial, most unforgivable flaw remained the inability to deliver accurate fire on the move. The cannon, being rigidly fixed within the hull, precluded the installation of any stabilization system that could compensate for the violent jolts and rocking of travel. Theoretically, the tank could fire while moving, but actually hitting a target was almost impossible. Every bump, every stone beneath the tracks would throw the aim off, sending a shell hurtling wide of its mark. For a precise shot, the entire vehicle had to come to a complete, vulnerable stop, a characteristic that severely limited its tactical options in any kind of offensive battle. The 1970s brought a revolution in tank design, an evolution in technology that would place a final, definitive cross on the future of turretless fighting vehicles. It was a monument to an ingenious yet ultimately flawed doctrine, a fascinating dead end on the long, unforgiving road of military innovation. For decades, engineers had wrestled with the fundamental paradox of armored warfare. They had created titans of steel, armed with cannons of immense power. Yet these machines were often rendered impotent by the very ground they moved upon. A solution, however, was finally at hand. They had perfected the intricate art of weapon stabilization. At last, a main gun, housed in its classic rotating turret, could remain locked onto its target, an unwavering eye in a storm of motion, even as its parent tank crashed and bucked across the most broken terrain. A complex nervous system of gyroscopes and lightning-fast servo motors now compensated for every lurch, every violent tremor, and every sickening roll of the hull, holding the barrel in a state of impossible stillness, perfectly aligned with the gunner's sight. The first production tanks to master this art, to achieve true two-plane stabilization, rolled out of Soviet factory. And with that, the very nature of tank combat was rewritten. The battlefield transformed into a high-speed arena, a place of continuous, frantic maneuvering. Machines converged not in ponderous lines, but in a deadly ballet danced at 50 kilometers per hour, all while delivering precise, aimed fire on the move. To stop, even for a moment, was to become a static target. And to become a target was to die. Mobility and the newfound ability to kill while in motion were now the absolute arbiters of survival. In this new, fluid reality, the Swedish Stridsvagn 103 found itself in the unenviable position of a sprinter with his legs bound together. All the ingenious advantages its turretless design had offered in the 1950s and 60s, the low profile, the excellent ballistic protection, were suddenly devalued by one simple, brutal fact. The Swedish tank could not fire on the move. All of its potential adversaries could. In an offensive engagement, the machine was doomed. Every halt to aim and fire was a gift to the enemy, an offering of precious seconds to return a stabilized, lethally accurate shot. The Swedish military command understood this problem with agonizing clarity, but there was nothing they could do. The tank's core design philosophy fundamentally prohibited the installation of a stabilization system. The gun was not in a turret. It was fused directly into the frontal armor plate. No gyroscope, no matter how sophisticated, could stabilize the entire 40-ton hull of a moving tank. The only conceivable solution would be a complete redesign, the addition of a rotating turret. But that would mean creating an entirely new vehicle, a betrayal of the very concept that made the STRV-103 unique. Despite this glaring technological gap, the S-tank continued its long service in the Swedish army. Military leadership reasoned, quite correctly, that the nation's defensive doctrine still relied on ambush tactics, a style of warfare where the ability to shoot on the run was not the deciding factor. A tank, hidden in a prepared hold-down position on a forest's edge, could wait patiently for an advancing enemy to present a target and destroy it from close range. It was for this exact style of combat, that of a patient predator, that the machine had been conceived. By the 1980s, an effort was made to stave off obsolescence. The tanks underwent a significant modernization, emerging as the S version. The machines were fitted with additional spaced armor across the front of the hull, a coarse steel grille designed to prematurely detonate the shaped charges of incoming anti-tank munitions. The old Rolls-Royce diesel was replaced by a more modern and powerful Detroit diesel, delivering 290 horsepower. A new 3-speed automatic transmission improved its acceleration and provided a smoother ride. It was a testament to a nation's ingenuity, but also a stark reminder that the cutting edge of one decade can become the liability of the next. The STRV-103 was a machine born of a specific threat and a unique philosophy. A brilliant solution to a problem that was about to be swept away by the relentless tide of innovation. On the unforgiving chessboard of war, even the most brilliant moves can be undone by a single, unforeseen change to the rules of the game. The fire control system was completely redesigned, its architecture brought closer to the standards of contemporary main battle tanks. A new generation of ballistic computer would instantly calculate every adjustment for a precise strike, accounting for dozens of parameters, from the temperature of the propellant charge to the very wear on the barrel. However, all these remarkable improvements could not alter one fundamental truth. The tank remained incapable of firing while in motion, a deficiency that grew more critical with each passing year. In total, 290 Stridsvagn 103 tanks across all variants would be produced. For 3 decades, these machines formed the very backbone of Sweden's armored forces, a silent, steadfast guardian of a neutral state's borders against any and all encroachment. Throughout their entire operational history, not a single serious failure leading to the loss of a vehicle was ever recorded, a testament to the exceptional and almost paradoxical reliability of a design so complex. By the 1990s, it became irrevocably clear that the time of the turretless tank had passed. A new breed of third-generation combat vehicles had arrived, equipped not only with fully stabilized main guns, but with computerized fire control, thermal imaging, and advanced composite armor. The Stridsvagn 103, even in its most modernized form, could no longer compete on equal terms with the L. In 1997, the last of these unique machines were withdrawn from service with the Swedish Army. For 30 years they had served their country, yet never fired a single combat shot at a real enemy. The concept of the turretless tank, born in the 1950s as a direct answer to the Soviet threat, faded into history alongside the Cold War that had conceived it. No other nation in the world ever dared to repeat the Swedish experiment. The Stridsvagn 103 remains forever one of a kind. A strange, brilliant, and utterly unique product of military engineering. A machine that was somehow both ahead of its time and ultimately its prisoner.